How you doing? This is Mr. Masseroni. We're going to be doing some notes on Unit 1, Part 3, the Binomial Theorem. And what we're going to be doing is basically showing you how to expand a binomial raised to a power and how to find terms in that binomial. We're also going to introduce the difference quotient, which is a concept that you'll be using going forward this year and on in mathematics. So when we talk about the binomial theorem, we're talking about two terms, a binomial, raised to a power. Now we know if we raise it to the first power, it's x plus y, okay, it's the same thing. Anything to the first power is itself. When we raise it to the second power, it's basically x plus y times x plus y, and you've all foiled that. You get x times x is x squared, x times y times x gives you the 2xy, and then y squared. Okay? And then as you go, we raise it to the third power. You see x to the third, 3x squared y plus 3xy squared plus y to the third. That's if you just keep expanding it. If you took, x squared plus 2xy plus y squared, and then multiplied it again plus xy, and then you did it again, and so on. Okay, that's what we call binomial expansion. Okay, you're expanding the binomial. All right, now some observations you're going to notice if you look at it. Okay, if your exponent is n, you're going to have n plus 1 number of terms. If you look back, 1, 2 terms. Your exponent's 2, 3 terms. 3, 4 terms. Okay, so you get one more term than the exponent. You'll also notice as the powers of x, now I say x, we should be talking about the first term. In this case it's x, but it's the first term. As those decrease by a power of 1, as the powers of y increase by 1. Okay, so you see the power of x, 2, 1, and technically x to the 0 power. And then this is technically y to the 0, 1, 2. And you see it, 3, 2, 1, 0. 0, 1, 2, 3. Okay? The sum of the powers of any single term is always n. So if you look, 2 plus 1 is 3. 1 plus 2 is 3. 3 and 3, if I went to here, 4. 3 and 1 is 4. 2 and 2 is 4. 1 and 3 is 4 and 4. Okay? So whenever you have variables in each term, you'll see that. And your coefficients increase and then decrease in a systematic pattern. Now what's going to change with this is if one of your terms were, say, x plus 2y, then you're multiplying that too. You're multiplying the entire term you're raising to the power. So you have to be careful with that, but I'm going to show you that along the way. Now in the form, in the basic form that we learned, the binomial theorem, this is how we expand it. Okay, x plus y to the n. Your coefficient is a combination of n things taken 0 at a time. Your x, your first term's exponent, starts with whatever your power is here, n, and your second term starts at 0. And then as you'll notice, a combination of n things taken 1 at a time. This exponent decreases by 1, this goes up by 1. Combination of n things taken 2 at a time. The exponent's down 2, this one's up 2, and on until you get n things taken n at a time. Your x, or first term's exponent, is 0, and your second term, the y, is n. Okay? If we wrote it in summation form, a summation where r starts at 0 and goes to n, a combination of n things taken r at a time, x to the n minus r power, you can put that in parentheses, and y to the r power. Okay? So you'll notice you have n here, your r would be 0, so there's n, 0, n minus 1, 1, it goes up. You'll see the patterns as it moves along. Okay? Now we have some rules for combinations. I'm actually missing a space in here. This should have been separated better. A combination of n things taken n at a time, you can only do once. Okay, if you have 8 things, there's only one way to take them 8 at a time. And on the flip side, a combination of anything taken 0 at a time is 1. When you have a group, there's only one way to take 0. Okay? 0 things taken 0 at a time, you can only do once. Again, I'm missing a space here. My apologies. N things taken n minus 1 at a time is n. So if you have 8 things taken 7 at a time, you can only do that 8 ways. Basically leaving 1 out every time. And 8 things taken 1 at a time, there's only one way to do that. Or there's 8 ways to do that. N taken 1 at a time is n. Okay? Now I'm going to get into actually expanding a binomial for you. And I'm going to show you the process. And the process I show, I'm going to use some colored pencils here to help you see it. Okay? So we're going to an exponent of 6. So we know we're going to have 7 terms. Now the way I've done this is we know there was 3 parts to each of it. The combination, the first term to a power, the second term to a power. And the way I do this is I handle each piece of it first. What does that mean? Well, I do the combination first. Okay? And that, we said, changes just like this every time. Plus, combination of 6 things taken 2 at a time, plus combination of 6 things taken 3 at a time. I'm actually going to take this on to the second line, plus 6 things taken 4 at a time, plus a combination of 6 things taken 5 at a time, and then the last term, 6 things taken 6 at a time. There's your coefficient. Now I'm going to work through the first term. My first term is x. So we start with x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, x to the 0. Now you guys know, being the mathematicians that you are, you never really have to write x to the 1st. You can just write x. X to the 0 we know is just going to be 1. Okay, anything to the 0 power is 1. Now the last term, my term is 3y, so it's actually 3y to the 0, 3y to the 1st, 3y squared, 3y to the 3rd, 3y to the 4th, 3y to the 5th, and 3y to the 6th. Okay? That's how you manage that through like that. I broke it up. Hopefully the colors help. Make sure when you raise this term to a power, it's both terms. Okay? So when you go through, and you can actually do the combinations and the powers of 3 in your calculator, I would advise you to give that a shot, just so you know what it looks like and how to get there. But your end result is going to be x to the 6th, this ends up being 1 and this ends up being 1, plus 18x to the 5th y, plus 135 x to the 4th y squared, plus 540 x to the 3rd y to the 3rd, plus 1215 x squared y to the 4th. Slide this over a little bit. Plus 1458 x y to the 5th, and plus at the very end 729 y to the 6th. Now some of you might be asking, I thought you said the coefficients would go up and down in a cyclical manner. They do somewhat. The difference is you're taking this 3 and raising it to a power each time and then multiplying it by your coefficient. That's why these don't look as clean as they did in the notes. When you looked at the notes, if you remember, 1 4 6 4 1, 1 3 3 1. It's, you know, it's a system, it's a symmetric pattern. You don't see that because of the 3 here. Now, what you can do right now is maybe pause the video to do the next one on your own, but I'm going to keep going here so that you understand what to do. I'm going to do another one. Now, you'll notice the difference here. What I've done is I've got a negative sign in here, so you have to be careful with that. All right? So again, I'm going to do the same thing. The combination of, it's in this case, 4 things taken 0 at a time, plus combination of 4 things taken 1 at a time, combination of 4 things taken 2 at a time, 4 things taken 3 at a time, 4 things taken 4 at a time. Okay? And then I'm going to do the first term is my 2x. So I have 2x to the 4th, 2x to the 3rd, 2x squared, 2x to the 1st, 2x to the 0. And then the other term, now you have to be careful because it's a negative y. So you have negative y to the 0, negative y to the 1st, negative y squared, negative y to the 3rd, negative y to the 4th. Okay? And moving those exponents around like that, I'm sorry, check that. Changing the signs back and forth like that is going to change the signs in your overall answer. Now, you can go through and expand this on your own. I'd advise you to. The answer, 16x to the 4th minus 32x to the 3rd y plus 24x squared y squared minus 8xy to the 3rd plus y to the 4th. Okay? Now I'm going to show you how to find a specific term. Okay? To find the rth term, whatever r is, it could be the 10th term, the 4th term, the 3rd term. Okay? To find the rth term of x plus y to the n, we use this formula, a combination of n things taken r minus 1 at a time, x to the n minus, in parentheses, r minus 1, times y to the r minus 1. Now, it looks complicated, but it's really not. From the standpoint, if you look, this number here, r minus 1, is going to be the same as that number right there. And then the 2 exponents we know add up to be n. So that shouldn't be a problem. Okay? So when I look to say find the 5th term of this expansion, okay, we're to the 9th power. So my n is 9, my r is 5. So I want a combination of 9 things taken r minus 1, so 5 minus 1 is 4. And then I'll actually look at it. My second term, negative 1, is the same exponent here. And I know that the 2 exponents have to add up to be 9. So 9 minus 4 is 5. And then you just go through and mathematically fix that up. 9 things taken 4 at a time is actually 126 times 32 x to the 5th times 1. And your answer, 4,032 x to the 5th. Now we only have one variable because I only had one variable here. Okay? I'll give you a minute. You should probably pause the video again. I actually skipped from 3 to 5. I don't know how that happened. It should be a 4. And you might want to go through this on your own. Again, it's 19th and 35. You're definitely going to need your calculator. But it's actually, we know that n is 35, r is 19. So we want a combination of 35 things taken 18 at a time. Y is going to be to the 18th. My second term matches here. And my 2 exponents have to add up to be 35. So 35 minus 18 is 17. The only real math here is 35 things taken 18 at a time. And that comes out to be 4,537,567,650 x to the 17th, y to the 18th. Okay, that's how you grab a term. I'm sure I'll be looking to do more of these in class as examples if you need them. One more topic for this video. We're going to talk about the difference quotient. Now, the difference quotient is something you need. We introduce it here. The definition, it's just a formula. Okay? F of x plus h minus f of x over h. And this is a concept that we will go back to throughout the course for different applications, and you'll also be using it as you go forward in calculus. And I'm going to show you how it works. We're going to expand the binomial in the difference quotient and simplify. Okay? So we know the difference quotient, f x plus h minus f of x over h. Now, how do we apply that? Well, here's my function. F of x is x to the third. So f of x plus h, we know from our function work, we're putting x plus h in for x. So it's going to be x plus h to the third minus x to the third, which again, we're putting x in for x now, all of that over h. And when you go through and you expand this, okay, it's actually similar to what we did on the first page. You're going to have x to the third plus 3x squared h plus 3x h squared plus h to the third, and then minus x to the third. All of that over h. Now it's just simplifying it. Getting to here is the heavy lifting. Now you just want to simplify it. You have a positive x to the third and a negative x to the third. If you look, I have an h in each of these, so I'm going to factor that out. 3x squared plus 3xh plus h squared over h. They can both cancel, and you're left with 3x squared plus 3xh plus h squared. That's the entire thing. We're just using it as a tool to help us practice the binomial work. We're not doing anything elaborate with it yet. We're just using the different quotient as a tool to practice the binomial work. Okay? And now, one last example. Okay? Again, f of x plus h minus f of x over h. Now, my function is x squared plus x. So when you look at it, x plus h squared plus x plus h, that's the first piece. That's this here, going into here, minus x squared plus x. Now I put that in parentheses because you understand you have to distribute this negative sign. Okay? Now we go through and we expand this. And the expansion comes out to be x squared plus 2xh plus h squared plus x plus h minus x squared minus x, distributing that negative sign. All of that over h. Okay, now again we're going to simplify a little bit. I've got a x squared and a negative x squared. I've got an x and a negative x. And then I'm going to be able to factor out an h from each term. And when I factor out the h, I get 2x plus h plus 1 over h. The h's cancel, and there's my answer. 2x plus h plus 1. Okay? If you have any questions, make sure you're asking them in class, sending emails, myself, Mr. Higgins, anybody from any class, that's fine. We'll take care of it. Hope everybody is doing okay, and that's it for this lesson. Thanks and good luck.